Machine Pencil Cartography. This channel's goals involve communicating navigational concepts to a general audience. Today, we will discuss unique navigational mechanics that are relevant to the operation of high-speed craft. So that I can demonstrate that this is a reputable concept and that it has a valid source of notoriety, the International Maritime Organization has adopted and maintained the definition of a high-speed craft for reference in international maritime law. This has inspired me to adopt and recognize this nomenclature in my own navigational practice. It is easily adapted for each type of navigational craft, including terrestrial, marine, and avian transportation. The premise of designing a high-speed craft is that the navigational vessel was specifically designed so that it could travel at speeds that exceed normal limitations. To illustrate exactly what this means, we may examine and document the unique mechanics that will arise in our craft while we are ambulating at each speed level. In classical ergonomic fashion, I will direct my viewer to comprehend these speed levels as if they were part of a level set. We can limit the complexity of the examination by noticing the similarities of operating similar navigational craft under roadster conditions, and our only independent variable should be how fast our vehicles were operating. Therefore, we will keep a level set examination for navigational craft, and we will keep in mind that our speed will be our independent variable. I will proceed to review a few unique mechanics that I have observed for vehicles moving at high speed. There are unique mechanics that will affect the operation of a terrestrial navigational craft. It is well documented in motorsports that during competitive races, the race cars will put out a large amount of mechanical energy, and these vehicles will coincidentally release a large amount of heat. In numerous documented occasions, these cars have gotten so hot during their races that they have erupted into flames right in the middle of the race. This is an interesting occurrence because race car drivers have been forced to adapt to this by wearing personal protective equipment in the form of fireproof uniforms made out of Nomex, the very same material that firefighters wear when they charge directly into a dangerous fire. For the purpose of preventing catastrophic damage to our persons or our vehicles, we will need to monitor the temperature and health of our cooling systems. Since our radiator, circulation systems, and our coolant are all instruments that will prevent car fires and damage to our engines during high-speed operations. For this reason, a person who is interested in operating high-speed craft should naturally be interested in their coolant and their heat management systems, as improving your cooling system will be a necessary step for advancing as a speedster. When reaching a mature comprehension of how navigational craft operate, we will take special notice to the fact that at each unique speed level, and as our vehicles exceed the slower speed levels, we will gradually experience a few new and unique attitudes from our navigational craft that were not present during our slower operational routines. An ergonomic explanation for this is that there are unique occurrences associated with high-speed operations. By definition, any time that we experience a unique attitude in our navigational craft which arose in the context of high-speed operations, these attitudes are considered excitations. One famous example of excitations arises in the context of operating high-speed craft in aviation. During the operation of the Concorde, which is an airplane that can travel faster than the speed of sound, it has been demonstrated that during these high-speed operations, the aircraft will cause a sonic boom. The sonic boom is considered an excitation because, as we have discussed, the sonic boom is a unique physical occurrence that has only arisen because the vehicle was operated at such a high speed. For this reason, the phenomenon of the sonic boom remains a notorious demonstration of excitation mechanics. Finally, we may examine an interesting mechanic that occurs while you are riding a bicycle. It has been demonstrated that a bicycle has poor balance while it is moving at slow speeds, and that a bicycle has improved balance while it is moving at faster speeds. This reflects the fact that a bicycle is balanced using gyroscopic forces, and this source of restorative energy is only available while the bicycle is moving. The fact that a bicycle is well balanced while in motion, but you lose balance when the bicycle stops moving, is a demonstration of an excitation mechanic, as we can show that balance was a privilege of motion. Thank you for watching. This has been Machine Pencil Cartography, signing out.